So new topic is the beam strength of think about the bevel gear. The beam strength of bevel gear is somewhat different with the spur and helical gear. Now the size of the cross section of the tooth and bevel gear varies with the face width. Just see this figure. Here we can see in the terminology also we have seen. So a spherical part is considered for the bevel gear, but for plane we use the back cone angle, and the teeth get reduced in shape as it comes towards the point O, that is the cone center. Okay, so for this here an elemental ring is considered here, having a thickness dx and radius rx, and this is the r for pitch circle radius from the pitch line, and this is the pitch line, or you can say the pitch circle radius, and here the beam strength, it is the strength beam strength is acting here. Okay, so this is AO. Okay, the center distance, this is the face width b, and this is dx, and this is the x distance from this O point, and this is the face angle, that is gamma. Now let's see, based on this we will get the equations. So Rx upon R is equal to x upon AO, or you can say the Rx is equal to x capital R upon AO. This we get here. At the elemental section, Mx is equal to 2 times Rx upon Z here. So 2xr. So based on this two equation, what we get, that at large end, always on bevel gear, just remember that we have to design the gear teeth on at the large end only. Okay, there is no for the small end, nothing is there for the small end. So m is equal to 2 times capital R upon Z. This is the things here. Now from C and D we get that mx is equal to m into x upon AO. This is the value for mx. Now bx is equal to dx. Putting this value we get delta sigma beam strength is equal to m sigma b y x dx upon AO. We are putting these values here from b and g, that is this b terms and this g term. What we get, this integrating term we get, we are integrating this part and we get the torque value here. Okay, this torque value we getting here. Now for solving this torque value we get this part, so we get this value, this is the maximum torque, you can say the torque. So beam strength nothing is but related to the torque. Now mt can be replaced with the beam strength as, let's see this part. Mt is equal to sb into r, because perpendicular force into, sorry, force into perpendicular distance, this, that is the torque. We got the value of mt, sb is there and r is there. So putting that sb is equal to this r we have transferred here. So what we get, mb sigma b y1 minus this, but this part is not very important for us, it can be neglected. It is 127 part, so it can be neglected. So we get the equation for beam strength as sb is equal to mb sigma vy into 1 minus b upon a0. Same equation, only 1 minus b upon a0 is added here. Okay, m is the module, b is the phase width, sigma b is the permissible bending stress, and y is the Lewis factor. So these are terms. 1 minus b0 is called the Bevel factor. This is known as the Bevel factor.